you're going to have some exponents on the, on the outside. Who remembers what you do with those exponents if it's on the outside? Yeah, and actually you multiply it times you multiply the exponent times the exponent. So 3 times 2 is going to be 4 to the 6th, and I also do it on this one. I multiply the exponent. 2 times 4 is 5 to the 8th. Did I do that right? Oh, that's it. I don't know why they're doing all this. Okay, they're just showing you each and every single little step, which I should have done. Okay, but anyway, that is it. Okay, write each group of like factors using exponents, then simplify by raising it. I am not going to simplify that. There is no way. Okay, so let's look at this one again. What are you going to do on this one? Yeah, you just multiply that 3 times both of them. 3 here and 3 here. So 2 times 3 is 6. 5 times 3 is 15, and we're done. That is it. And they're going through each little step if you want to look at that again. All right. This one here, I'm not crazy how they're doing it, because they've got, they're causing you to have negative exponents, and then you switch it. I kind of like to switch it right in the beginning, because where should this 4 be? It should be at the top, so it's 4 to the positive 1, and then this one would be 3 to the positive 2. I prefer switching it right in the beginning, and then apply your exponent. So it's going to be 4 to the what power? 4 to the 3rd power over 3 times 2, 3 to the what power?
6.
3 to the 6th. So we get the same thing, but I think it's a little bit more efficient if you work with positives. And then over here, let's see what's going, oh, that's ugly. What's coming up is ugly. Alrighty. So I would, what would you maybe do here first? I'm going to do a little different than what they're doing. I would get rid of that m to the 0. Anything to the 0 power is what?
1.
Is 1. So all I have right now on the top is 5. But I'm also going to take this n. Where should I put it? I'm going to put it at the top. So in all reality, again, I'm going to do what I can inside. So in all reality, again, this becomes a 1, and I'm bringing that n up. So I've got 5n squared, and then to the 6th. Then, again, I think they're working too hard. Okay. Then that 6 gets applied to each little number. So it's 5 to the 6th, and then n to the what power?
12.
To the 12th. And I think that should be it. In fact, that's it right there. All right. If you want to work with negatives, you can. I prefer not to. So this is a big, long explanation. Oh, let me see what they're doing. They're first getting everything in improper form. So let's see what if we're going to work this ourselves. So it's going to be 2/3 times, what is this going to be in the improper form? 3/2. And the whole thing, in fact, I'm going to separate it right now. What happens to each of those? They get taken to what power?
4.
To the 4th. So I'm going to sort of separate these, and this is going to be to the 4th, and that's going to be to the 4th. And then on the bottom, I've got 2/3, and this one's going to be what?
Negative.
A negative 3/2. In fact, I'm going to put the 3/2 here to the 3rd. And by the way, since I've just got one negative, in fact, I don't have just one. it's how many negatives if I put it right here? It's going to be 3 because it's a negative. I don't want to mess that up. It's a negative times another negative times another negative. Okay. So it ends up being an odd amount of negatives. So if you've got an odd exponent and it has a negative, the whole thing is going to be what? The whole thing is going to be negative. So I can take that. I removed it from here and I'm going to put it right out here. I just don't want to lose it. Okay. So now look at it. Doesn't 2/3 match 2/3? So we can apply our exponent rule. There's 4 here minus 1 here. What are we going to be left with? 3. So it's going to be, and again, it's going to be more on the top. So I think I'm going to lose my denominator. So it's going to be 2/3 to the 3rd power. And then who knows what's going to happen here? These are the same. It's going to be what? It's going to be 1. 3/2 to the 1st power. And again, the whole thing's negative. And I think they want to, why did they get a 2? Did I do something wrong? They got 2/3. Oh. Change. I don't know what they did. I do not know. But I'm going to just continue and see if we get the same answer. So I'm going to take it out and go 2/3 times 2/3 times 2/3 times what? Times a 3/2. And then does anything cancel out? Doesn't this and this cancel? And the 3 and the 3? And our final answer is 4 over what? And we had our negative. So it's going to be negative 4 over 9. We got the same answer. They're saying that you can flip this when you apply the negative. You can flip it to a, I don't know what they're doing. You can flip it to a positive. I don't know what they're doing. I just like to put things in positive form because all the negatives hurt my head. So let's go ahead and see if we can do some of these. How many do we have? This is a lot. These are just more rules. Here are some of the rules. This should have been on the front. So these are the rules that you just simplify it to a single. So we've already done some of that. If I had 2 negatives here, I would multiply them, so it gives me a positive. And I don't think I would do it their way here. I would just make that to be a 1 right away. Why would it be? Why is it going to be a positive 1? So it's going to be 1/1. Well, maybe you have to. Negative. 0 times that is, and it's 1. Anyway, I'll try to figure this out, why that negative 8 comes to a positive 1. But anyway, let's look at anything else. We've already done this. It gets applied to both of them. And those should be easy. Alrighty, so let's just pick out a couple of these. Let's maybe do this one right here. Okay. We'll do both of these. So on this one, what's our new numerator going to be? If I apply this negative, what is it going to be? Negative 12. So it's W to the negative 12. This bottom one is going to be V to the what? V to the negative 15. But now we have to switch them. So that becomes the V15 and W12, and you leave it just like that. And then let's see if we can do a couple of these harder ones. Okay. Alrighty. I could go through the process of switching everything, but I'm going to have to switch again anyway with the -1. So I think I'm just going to go ahead and Oh, no, I'm not. There is something I can do first. What should I do with these two right here? They're the same base. So what's the rule of getting these exponents together? Add them. So 3 minus 2 is going to be 3 to the 1 over, these are the same base, so it's going to be 2 to the what? 2 to the third, and then apply your negative exponent. So it's going to be 3 to the negative 1 over 2 to the negative 3. And then what happens with both of those? They switch. So the 2 comes on top, and the 3 to the negative 1 goes on the bottom. And simplified, I don't know if they want the real answer or not. We're going to leave it like that. Then we'll do one more of these, and then we're going to flip it to yours. Okay, so this here becomes, I'll move that over here. So this becomes 1/2, that 3 gets applied to everything. So that's going to be to the third. Then this x is going to be x to the what? Negative 12, because 3 times negative 4 to the negative 12. And then the y is going to be y to the what? Y to the 6th. And so, what's 1/2 times 1/2 times 1/2? On the bottom, it's going to be 2 times 2 times 2. What? 1/2 times 1/2. People, isn't that going to be 1/8?
Oh, yes.
Okay. Okay, so it's going to be 1/8. And then we've got, where should that x go? Should it be on the top or the bottom? It's got a negative. It goes on the bottom. And this y is fine up here. So y to the 6th. So my final answer, once I clean it up, is going to be y to the 6th over 8x to the 12th. Huh. All right. These look fun today. Woohoo! Now, there's a lot. We can take 2 days to do this if you want, because we only did one from yesterday. Do you want to do 2 days on this? Yeah? Because I would like you to really do all of them. So, how about, I'm going to help you, I think, let me stop and get some paper because I might need some. Keep it if you want. Use it if you want.
Thank you.
Yeah, and you can put your homework on that sheet if you want. Get it. Max. Okay, so let's kind of get this all together. So, all right. How would you tackle, we're going to do some of your harder ones, and then I'll leave you with some of the easier ones. Look inside here. What would you do first? Could I reduce 3 over 9?
Yes.
Yeah, so I'm going to do this one probably on the paper. I'm going to start it on the paper. So I'm going to start by reducing that, negative 1 over 3. And then can I do anything with these A's? Yeah, or I could just look at it and say, I've got 3 here and 5 here. How many am I going to cancel off? How many can I cancel off? There's 3 of them here, 5 here. Can't I cancel off 3? Yeah, I can cancel off 3. Where are the A's going to be left, on the top or the bottom? on the bottom. And how many more are there? 2. So it's going to be a squared. And then let's look at our b's. Where are there going to be more b's left when I cancel? On top or bottom? Top, how many more? 5. And again, this is an easy one. 7 minus 2 is 5. So that's going to be b to the 5th, and then the whole thing squared. And I can actually get rid of this one now. I really don't need it. Okay. And so now, this is a bad time not to have an answer bank, but it is what it is. All right. So what is this top number? B to the what? B to the 10th. B to the 10th over, we've got to apply this 3 squared, and the a squared, we've got to apply that square. And in fact, I forgot something. I also have to apply the square to the sign, because this ends up being, if I wrote it out a second time, I'm going to have a negative times the exact same thing. So a negative times a negative is a what? It's going to be a positive. So when you have a negative on the inside with an even exponent, your answer is going to come out positive. So I can actually get rid of that. So our final answer is going to be b to the 10th over, what does this come to? 3 times 3 is 9. And then a to the what? A to the 4th. Oh, okay. Let's look at your number 37. Is there anything we can do on this first? Yeah, we can make that a 3, and it's going to be on top. And there's no other x's, so that has to stay here. X to the 5th. What can we do with the y's? So if you're subtracting, it's 3 minus a negative 2. 3 minus a negative 2. So what happens there? It becomes a positive, and so 3 plus 5 is going to be, I'm sorry, 3 plus 2 is 5. Or I could have just moved this up. It would have made it a positive y second, and then just add them. So what's our final y going to be? Y to the 5th, and I lose my denominator. So it's just this now, and everything to the 3rd. So it's going to be 3 to the 3rd, x 5 to the 3rd, and y 5 to the 3rd. And I think from there we can get our final answer. What's 3 times 3 times 3? So it's going to be 27. X to the what? X to the 15th. Y to the what? Okay. Wow, these are, I think, harder than yesterday. Okay. But do you kind of get it? Let's look at the 38. Okay. Alrighty, so what can I do with these two here? Is what? What is it going to end up being if you subtract them? Okay, did everybody see what she did? It was like, and I'm going to leave this negative here just for a second. It's m negative 4 minus the 1 on the bottom. And so it creates a what? Creates an addition. And I end up with m to the negative 2. But where should a negative 2 end up being? On the bottom. Or I could have moved this here. I could have put this here, the 2, and made it a positive. Made this a 4, taken the one from the top. And then I can see I've got more left over on the bottom. I've got 2 more on the bottom. So that is going to be m squared. Then, what happens with the p? Can you just see it mentally? And it's going to be where? On the top or the bottom? On the top. Okay. So we're done with that. Now, who knows what our sign is going to be? Yeah, it's a positive because we've got an even exponent, because we would have this times another one of those. So it's going to be positive. And then we're going to apply this to both. So it's p squared over m squared times 2 also. So our final answer is what? P squared over m to the 4th. Whoops. Sorry about that, people. Alrighty, we're going to do these last 2, the hardest ones, and then I will let you go on your own. Alrighty. But the whole point is, don't try to apply this negative in the beginning. I think it's easier to simplify this. So where the 3 is going to stay where it is, stays on the bottom. What can we do? If I brought this x up, it's going to be x to the what? It's going to be x to the 6, because this negative comes up as a positive 2, and I already had 4, so it's going to be x to the 6th. And then, who thinks they can tell me about the y's? What's the exponent of the y going to end up, and where? Well, just inside here. I'm not looking at this. So just these 2 y's right now. If I bring this y to the negative 4 down, it becomes a what? It becomes a y to the positive 4, and I already had 1 here. So it's going to be y to the what? Yeah, and on the bottom, y to the 5th. And then we're going to apply our negative 3, which is going to end up, I think, flipping everything. Is that right? It should, but I'll do it right here. So this one's going to be x to the negative 18. Then we've got 3, or we're applying that negative 3 here to the negative 3. And y 5 times the negative 3. Whoops. I could have saved myself some writing. So I think we'll do the rest, just get our final answer. Where should this x end up being? On the bottom. And where should this 3 end up? And as we're bringing it to the top, let's undo it. 3 times 3 is 9, times 3 is what? 27. And then this is going to be y to the 15th, negative 15th. Where's it going to go? It's going to go on the top as y to the positive 15th. And that's it. That's your final answer. Oh, these are tricky. Alrighty. I don't think I like this one at all. And I don't have the answer book. Just tell me if I'm getting it right or not, but we shall tackle it. Okay. So this one, there's no denominator, so I'm going to apply, I'm just going to take those each out, go 1 over 2 to the negative 2, y negative 7 to the negative 2. Oh, I'm sorry, that's x. Nobody caught me. Y to the 3 to the times negative 2. So if I'm applying this here, this is going to be to the negative 2, negative 2. And because I don't like negatives, I'm going to switch it right away. And so that 2 to the negative 2 goes on top. And that 1 to the negative 2 goes on the bottom as a positive. But what's going to end up happening with that 1? Do I need the 1 anymore? No, because I'm just dividing by 1. This one is going to be x to the what? Positive or negative 14? Positive 14. This one is going to be y to the negative 6. So let's put things where they belong. Okay, the 2 stays on top. 2 times 2 is 4. The 1, do I need this 1 anymore? 1 times 1 is 1, so I really don't need that. The x to the 14th is going to stay on top or bottom? It's going to stay on the top. And y to the negative 6 is going to go where? It's going to go on the bottom. Oh, these are my kind of fun. All right, so it is going to be 4x to the 14th over y to the 6th. Wow. Okay, people. I just need to know what time it is. Who's got the time? Who's got the time? I should have. That's and we're going to decide which ones to do. Let me shut this off for